The evolution of Microsoft's frameworks for web and application development is a story of addressing technological challenges, adapting to industry trends, and driving innovation. Here's a deep dive into how each framework evolved, what problems it solved, how it impacted development practices, and how it shaped the industry. ASP Classic was introduced with iOS, or Internet Information Services, 3.0. It was Microsoft's first server-side scripting language for dynamic web pages. Developers used VBScript or JScript to embed logic within HTML. Why it was introduced to compete with early web technologies like CGI, which stands for Common Gateway Interface, and PHP, to enable developers to create dynamic server-rendered web pages easily. How it worked: mixed server-side logic with HTML directly in files, processed requests via a scripting engine and generated HTML for the browser. Shortcomings: scalability issues, single-threaded execution, limited handling of concurrent requests, no code reusability. Logic and UI were tightly coupled. Limited debugging. Debugging tools were primitive, relying on manual logging. Security flaws. Basic mechanisms for input validation and security often resulted in vulnerabilities like SQL injection. Impact on development: provided an entry point for developers into web development. Simplified dynamic web development compared to CGI scripts. ASP.NET Web Forms was a major leap forward, introducing a compiled, event-driven programming model. Part of the .NET Framework 1.0, enabling developers to write applications in strongly typed languages like C# and VB.NET. Why it was introduced: to provide a richer development experience compared to ASP Classic, to abstract the complexities of web development using a drag-and-drop interface similar to Windows Forms. Key improvements: event-driven model, enabled developers to handle events like button clicks on the server side. View state, allowed state persistence between HTTP requests. Server controls pre-built UI components, simplified UI creation. Compiled code, boosted performance and allowed type checking at compile time. Shortcomings: view state overhead. View state bloated the page size, impacting performance. Poor control over HTML. Rendered HTML was often non-semantic and bulky. Complexity: the page lifecycle and event model were hard to grasp for larger projects. Scalability issues: view state and server-side controls did not scale well for high-traffic applications. Impact on development: enabled rapid application development for smaller form-based applications. Favored enterprise developers transitioning from desktop to web development. ASP.NET MVC introduced the Model View Controller architectural pattern to ASP.NET. Separated concerns, giving developers more control over the HTML, URL routing, and business logic. Why it was introduced: developers demanded more control over HTML rendering and better testability. The rise of REST APIs, clean URL structures, and modern JavaScript frameworks like AngularJS necessitated a more flexible approach. Key improvements: separation of concerns, isolated UI, view, business logic, model, and application flow, controller. Routing: clean, SEO-friendly URLs. Full control of HTML. Developers could handcraft HTML for modern responsive interfaces. Testability enabled unit testing and integration testing for better code quality. Shortcomings: steeper learning curve. Compared to web forms, developers needed to understand MVC architecture, lacked rapid UI tools, no drag-and-drop UI design, unlike web forms. Limited cross-platform, still tied to Windows and iOS. Impact on development brought .NET development in line with modern web practices. Increased adoption among developers building REST APIs and single-page applications, or SPAs. Sparked a shift in industry standards toward modular, testable application development. ASP.NET Web API was a framework specifically designed for building HTTP-based APIs. It separated API development from web application development. Why it was introduced: the rise of mobile apps and SPAs created a demand for lightweight, stateless REST APIs. Existing frameworks like ASP.NET MVC were not optimized for API development. Key improvements: HTTP-centric design, built specifically for HTTP methods such as get, post, put, delete. Content negotiation, automatic response formatting based on client request headers, whether it's JSON, XML, or others. Stateless design, better suited for scalable applications. Lightweight framework, focused solely on API concerns, reducing unnecessary overhead. Shortcomings: fragmentation. Having separate frameworks for web apps like MVC and APIs like Web API increased complexity. Impact on development: facilitated the rise of mobile-first and cloud-based architectures. Empowered developers to build scalable, RESTful APIs that could be consumed by a variety of clients. ASP.NET Core was a complete rewrite of ASP.NET, designed to be cross-platform, lightweight, and modular. It unified Web API and MVC into a single framework. Why it was introduced: to address the fragmentation of ASP.NET, which had separate frameworks for web forms MVC and Web API. To compete with lightweight cross-platform frameworks like Node.js and Ruby on Rails. To enable microservices and cloud-native application development. Key improvements: cross-platform runs on Windows, Linux, and macOS. Modular and lightweight developers include only necessary libraries, reducing the application footprint. Unified framework, combined MVC and Web API, simplifying development. Dependency injection, built-in DI for better modularity and testability. Improved performance: ASP.NET Core became one of the fastest frameworks for web development. Kestrel Server, a lightweight, high-performance web server optimized for ASP.NET Core. Shortcomings: breaking changes. Migrating from older ASP.NET frameworks required significant effort. Impact on development: revolutionized how net applications were built, enabling cloud-native and containerized development. Encouraged adoption of modern DevOps practices and CI/CD pipelines. Attracted developers from non-Microsoft ecosystems due to its open-source nature. Starting with .NET 5, Microsoft unified .NET Core and the .NET Framework into a single platform for all application types, whether it's web, mobile, desktop, or cloud. Why it was introduced? Well, to eliminate the confusion caused by multiple frameworks, like .NET Core versus .NET Framework. It aimed to provide a consistent and unified development experience. Key improvements included a unified platform with a single SDK, runtime, and libraries for all app types. There were continuous performance enhancements in the runtime, making .NET a top choice for high-performance applications. C# advancements introduced modern language features such as records, pattern matching, and nullable reference types. Blazor enabled building interactive web UIs using C# instead of JavaScript. Additionally, Microsoft provided stable, long-term support, or LTS, for enterprise adoption. The impact on development? It unified the ecosystem, simplifying the developer experience, and made .NET a leader in modern software development for cross-platform and cloud-native applications. Standardization has been a key role of .NET frameworks, setting industry standards for performance, scalability, and security. Enterprise adoption: ASP.NET robust tooling and enterprise-grade features have made it a favorite for large-scale applications. And let's not forget community growth. The move to open source with .NET Core has significantly expanded the .NET developer community. Looking ahead, there's enhanced support for cloud-native architectures, including serverless computing, microservices, and containerization. In the realm of AI and machine learning, there's deeper integration with tools like ML.NET, and WebAssembly, via Blazor, is positioned to enable full-stack development without the need for JavaScript. In summary, the evolution of Microsoft's frameworks reflects their commitment to solving real-world developer challenges, embracing modern trends, and staying competitive in an ever-changing industry. Each iteration has been a response to specific limitations and industry demands, driving the net ecosystem forward.